Hi everyone, Mr. Rodriguez here with another video for you guys. This time we are going to be looking at the volume formula of pyramids and cones. So you've already learned a little bit about this in previous lessons, and we're going to be doing a little more about this today. So let's take a look at our exploratory challenge here. So our first question is, what is the formula to find the area of a triangle? Well, if you remember, the area formula for a triangle is area equals 1/2 times base times height, right? So if we have a triangle that looks something like that, the base would be the bottom side over here, and the height would be how tall it is. In this case, since this is a right triangle, that would simply be how long this side is over here. For part 2 over here, explain why that formula works. Well, if you remember, this formula here is derived from, or it comes from, the area of a rectangle. Let's take a look. So let's say we have a rectangle, and let's say, remember that the area of a rectangle is length times width. So, whoops, that's not what I want to do. So length times width, right? So you have to realize now that a triangle is really just half of a rectangle. So do you see this, how this side over here, or this part over here, forms a triangle? So our area formula for a triangle, it makes sense because it's just 1/2 of the area of a rectangle, right? So it would be area equals 1/2 times length times width, right? Length times width was the area of a rectangle. And of course, as you know, when we're talking about a triangle, we usually use the terms base and height, right? So it would be area equals 1/2. The length, in this case, is the base, and the width is the height. So instead of L, we would have B for base, and instead of W, we would have the height. So that's how you get the formula for a triangle's area. Let's look at our next challenge question over here. What is the formula to find the volume of a triangular prism? So if you remember a triangular prism, it's a little hard for me to draw, but it might look something like this. You kind of have a triangle as a face, and then remember it's a three-dimensional shape, or a solid. And I know it might be a little hard to envision, but you have to keep in mind that this is a 3D shape. So over here, this is like the bottom on this side, and this is the bottom over here, right? These points up here are the top, right? And they kind of connect, right? It would almost look like maybe like a sharp version of like a Twinkie or something, right? You have to keep in mind this is three-dimensional here, so this is kind of like the top up here. This like side here is one of the bottoms, right? So what is the formula to find the volume of this triangular prism? So if we remember, for any 3D shape, the volume is always going to be base times height, right? You're taking the base and multiplying it by the height. Now for a triangular prism in particular, we know that the base is a triangle, right? See, each side has a triangle on it. And so we need to find the area of the triangle. Well, we know from before that that's um, the area is 1/2 base times height. So 1/2 base times height, right? So that takes care of our base, right? And then we take this and we're multiplying it by the height of the 3D shape. Now you have to be a little careful here. So the triangle formula has a height, right? The height was kind of how long the triangle was, right? But it's going to be a little different now from the height of the 3D shape, right? The height of the 3D shape is like this, right? So I might choose to call the height of the 3D shape, maybe I'll just call that H2, just to recognize that this second height here is different from the height we used over here. So to explain why the formula works, well, you basically have to imagine that for any 3D shape, I think it's kind of easiest if we look at maybe something like a cube. Well, let's say instead we look actually at a cylinder. That might be a little easier to see. So cylinder, if you remember, was something like this, right? And again, for any 3D shape, volume is going to be base times height. So really, the way you kind of think about it is what you're doing when you take the area of this base here and multiplying it by the height, you're basically just saying that this cylinder here is basically made of circles that are just on top of each other, right? This is a circle here, that's a circle there. And it's basically just made up of circles that are right on top of each other, right? It's like almost like a pile of pepperonis or something would make a cylinder, right? So it's the same principle for this triangular prism up here. The triangular prism is really just made up of triangles that are on top of each other. So you just take the area of one triangle and multiply it by the height. So we could kind of write, if we want to put this into words, it works because the volume of a triangular prism is just a series of triangles stacked on top of each other. Let's look at our next question over here. So what is the formula to find the volume of a cone or pyramid? Well, again, if you remember from previous lessons, volume of a cone or pyramid is just volume equals 1/3, whatever the base is, times the height. So to explain why this formula works, well, you basically just have to remember a cone, right, looks something like this. So you basically just have to remember that a cone is just 1/3 of a cylinder. So this is a cone here. Let's say, do you kind of see how I could make a cylinder, right, using that same base. So do you see how this cone kind of fits inside the bigger cylinder? So the volume of a cone happens to be, right, a third of the cylinder. Right? So if you remember, the volume of a cylinder, right, is just the base times height. So that would be pi r squared times height. So this is volume for a cylinder, right? And then volume for a cone would be 1/3 pi r squared times height. And for a pyramid might look something like depending on what kind of pyramid it is. It's a little harder to draw, but something kind of like this. A little sloppy there, but you see how you have this sort of square base and you have kind of sides from each point here, right, going towards the center up here. So it's a pyramid, right? And again, it's the same idea. A pyramid is almost like it's like 1/3 of a cube, right? I won't really attempt to draw that here, but you could kind of imagine that. So then it's really just 1/3. And then again, it's the same base times height. So the base here would be like, if this side is called S, it would be S squared times height, right? Because S squared is the formula for area of a square. So let's look at our first exercise over here. Our first exercise says a cone fits inside a cylinder so that their bases are the same and their heights are the same. So this is kind of similar to what I drew up here, right? This is just a better drawing, right? So we see we have our base, right? This circle down here, right? And then it says we have the cylinder, right? Which is, right, this part. And then we have the cone, which is, let's say use a different color here. See how the cone is kind of like this part over here? So, right, they share the same base there, but once we get beyond the base, things get a little different, right? The cone is much smaller. It's inside the cylinder. That said, we notice that they share the same height, right? The height is from the top, right, to the bottom. So that's the same for both the cone and the cylinder. Okay. So let's erase this. So now our problem is to calculate the volume that is inside the cylinder but outside the cone. So to kind of imagine that, the volume that's inside the cylinder. So the cylinder is the bigger one, but outside the cone. So it's basically all this space. And so this is kind of like, if you remember from class, this is kind of like a shaded area problem, right? Do you remember when we took the area of the bigger shape and subtracted the area of the smaller shape to find basically the difference in area between the two shapes? This is the same idea here. You're taking the volume of the larger shape, right, the cylinder, and you're going to subtract the volume of the smaller shape, the cone. So let's take a look at the volume of, say, the cylinder first. So our volume formula for the cylinder, I'll do V, and we'll say Cy for cylinder, is, right, base times height. So it'll be, our base is a circle, so it's going to be pi r squared times height. So again, all we have to do now is just plug in the numbers. So we have the volume of the cylinder equals pi. Let's say we use 3.14 for pi. Then our radius we have is 5, right? So times 5 squared. And then our height we have is 12. So now all you have to do to get our final volume here is multiply all these things together. So you can use your calculator for that. And let's see. So I got 942. So our volume is 942. If this were in inches, then this would be inches cubed, right? So maybe we could just say generally it's like units cubed, whatever measurement we're using here. But we're not done yet, right? That just gave us the total volume for the whole cylinder. Now, as I said before, we need to find the volume of the cone here, right? Everything that's inside the cone. So, I don't know, let's keep red here, why not? So the volume of the cone now is, well, we have the same base, right? It's a circle, and the height's the same. So really everything is the same. Pi times r squared times height. But if you remember, we said a cone is 1/3 as big, right? As the cylinder, right? So now again, we can just plug in all the numbers we have. So 1/3. For pi, we're going to use 3.14. Radius squared, it's the same, right? Times height is 12. Now we can be a little lazy here, right? We actually already know what the answer to that is, right? The same as this. So then it's just 1/3 times 942, right? So let's say 942 times 1/3 equals our volume of the cone. So let's do times 1/3. You could do times parentheses 1 divided by 3. And you should get your volume of the cone equals 314. And so now we have both, right? We have the volume of the inside and the volume of the whole thing. So now to get what the volume of what's in between, right, the cone and the cylinder, all you have to do is take this number up here and subtract this number here, right? So let's say let's say use blue here, our volume, right, of the shaded region. Let's say volume of the shaded region, why not? Equals, right, the volume of the whole cylinder minus the volume of the cone. And all that is equal to, let's see, 942 minus 314. And you should get 628. And again, we could say units cubed if we want. just to emphasize that it's volume. And so again, this number here is a measure of the amount of space, right, between the whole cylinder and the cone. So I'm not going to actually do these problems. I don't want to make this video too long for you guys. But just to take a quick look here, this problem over here, all you would have to do is find the radius over here using the Pythagorean theorem. And then once you do that, you would be able to just use the volume formula for a cone, right? And this problem here, number 2, is really just a reverse problem. So it gives you the volume right over here, and then it's going to ask you basically, so it's going to give you the volume to begin with, and then you're basically going to have, so you're going to have to find the length of one side of the base and the area of the base. So then you plug in the things you have, right, into the volume formula for a pyramid, and then solve for what you don't have. That's how you would do those. But as I said, you don't have to do these 2 problems here. So what you guys should work on now, your actual classwork, is the problem set. This problem's 1 through 6. Good luck, and feel free to reach out to us if you need any help with anything.